We're continuing in 4.2, series voltage sources, and we'll be looking at series aiding and series opposing. Many electrical circuits have more than one voltage source, and these sources may be series aiding or series opposing. Series aiding voltage sources are sources that are connected so that current in both sources flows in the same direction. Okay, series aiding. It's saying so current flows in the same direction from both voltage sources. So if you look at it here, we have a power supply. Here we have current flowing, and if it's negative to positive, current is flowing in this direction, and the other voltage source here, current is flowing, and they're both connected in the same, so the current flows in the same direction. And most of the time, if we're using batteries, this is the way they are set up. The effective voltage in a series aiding circuit is the sum of the series aiding voltages. And so in this case, we have 15 and 5. So we have series aiding, so we will add up the values. This is much like you would have if you had a simple flashlight, and here you've got the flashlight and the little light bulb here, and you probably have two batteries, maybe the 1.5 volt variety, and this is probably a 3 volt light bulb, and so you'd have series aiding. Now, series opposing voltage sources. Now here, series opposing sources are connected so that sources cause current to flow in opposite directions. Now notice this circuit. Here we have 10 volts, we have 25 volts, and the current, notice on this one the current is flowing this direction. On this one the current is flowing this way. And so in this particular case we would say, well, in reference to ground here, we have 25 volts, and we have opposing it, we have a minus 10 volts, and so our net voltage here is going to be 15 volts, and that's what we call series opposing. And then there are complex voltage sources. Many circuits involve a combination of series aiding and series opposing voltage sources. These types of circuits are referred to as complex voltage sources, and the effective applied voltage is the algebraic sum of the voltage. And notice here the voltage total, plus or minus V1, V2, etc. Now in this one, let's first of all look and see what is opposing and what is aiding. And so we could look at our batteries. Here we have 50 volts, we have positive polarity here, negative, and then going down here to a positive to a positive to a negative. And if we evaluate, we will see that all three of these they aid each other. And so we have 50 plus 20 plus 10, what is that, 70, 80 volts. We have 80 volts going in this direction. And then you'll notice here we have the positive connected to the positive, so this is going to be an opposing voltage. And so in this case we would have minus 75. And so our net voltage here would be plus 5 volts. And if we wanted to summarize this, let's see, we could say here we could put, let's put a battery here, and this would be RT, this would be all these resistances, and we could say this was 5 volts. Now there's no ground in this circuit, so whether we say that this is a positive value or a negative value is somewhat relative, because we could have started this circuit out looking at this as the starting point, and if we had, we would have said, well, it's 75, and we would have subtracted these, and so then we would have had we would have ended up with a minus 5 volts. Now in that case we would have had something that looked kind of like this, and we would have said we'd have RT over here, and we would have said that this was a minus 5 volts. Now, keep in mind when we have not talked about this business of negative versus positive voltages, and the only difference between a negative and positive is which way is the current flowing. Now, typically in this one, we would say, well, current is flowing from negative over here to positive, but since we're saying it's a negative voltage, actually we're going to flip it over. We're going to say just the opposite. The current is actually going from here to here, just the opposite. Now, if we were to change the polarity here to this, we would have to flip the polarities of our battery, and then it would look just like this. So electrically speaking, whether we call this minus 5 volts across RT, or whether we show it drawn like this as plus 5 volts across RT, electrically current is going in the same direction, and this is the same as this. Okay, we've taken a quick look at series aiding and series opposing voltages in series circuits. So this was our complex voltage source. Then we showed a series opposing, and then we started out with series aiding.